So dear students, in this class let us discuss about a new property of Laplace transforms. It is known as convolution property. The property is known as convolution property. What is convolution? Convolution property means if f of t and g of t are any two functions having Laplace transforms f of s and g of s respectively. That means L f of t equals f of s and L g of t. L g of t equals g of s. Then the convolution property is stated as, or the convolution of this f and g is denoted as f star g and is defined as f star g of t equals integral 0 to t f of t minus u g of u du. So this is the convolution property. If f of t and g of t are any two functions having Laplace transforms f of s and g of s respectively, then the convolution of f and g is denoted as f star g and is defined as f star g of t equals integral 0 to t f of t minus u g of u du. Means the convolution of f and g is nothing but the inverse Laplace transforms of the products f of s and g of s. That is L inverse of f of s into g of s. L inverse of f of s into g of s equals integral 0 to t f of t minus u g of u du, that is f star g of t. Okay, so L inverse of f of s and g of s is another meaning of the convolution. The convolution of two functions is nothing but the inverse Laplace transforms of the products of their Laplace transforms. Means L inverse of f of s into g of s. The inverse Laplace transforms of product of f of s and g of s is nothing but f star g of t. So from here we know that what is f of s into g of s? F of s into g of s is, from here it is f of s into g of s is Laplace of f star g of t. Okay, so this is the convolution. So this is important. If f of t and g of t are any two functions, then their convolution is defined as f star g of t is integral 0 to t f of t minus u g of u du. That is L inverse of f of s into g of s is nothing but integral 0 to t f of t minus u g of u du. Means the convolution is nothing but the inverse Laplace of the products f of s and g of s. Again, the convolution is commutative. That is f star g equals g star f. This is the commutative property. Commutative property. The convolution is always commutative. How to prove this one? So far, the proof is, what is f star g of t? F star g of t equals integral 0 to t f of t minus u g of u du. Okay. So put a t minus u equals y. Put a t minus u equals y. So this implies when t equals 0, come to the limit of u. When u equals 0, when u equals 0, what is t? Sorry, y equals t. Y equals t. Okay. When u equals t, upper limit, what is y? Y equals 0. Again, t minus u equals y, then by the s, t minus u equals y. So what is g of u? T is a constant. So minus du equals dy. That means what is du? Du equals minus dy. Agree? t is treated as a constant. Therefore, the integral becomes integral instead of 0 to t. Instead of 0, here it is t. Instead of t, here it is 0. Okay. When u equals 0, y becomes t. When u equals t, y becomes 0. So integral t to 0, f of, what is t minus u? It is y. Y into g of, what is u? From here, u is t minus y. So it is t minus y. What is du minus dy? That means take negative outside. So it is minus of integral t to 0. What is minus of integral t to 0? That is integral 0 to t. Its limits are interchanges. 0 to t, f of y into g of t minus y dy. F of y into g of t minus y dy is nothing but it is g star, that is g star f. Okay, so it is f star g is always same as g star f, that is the star means convolution is always commutative. Clear? Similarly, the convolution is distributive. What is the distributive property? Convolution is distributive as well as this convolution is associative and so on. Convolution is distributive, convolution is associative, or as well as convolution is commutative. What is the distributive property? If f, g and t, three are h, f, g and h are any three functions, then f star g plus h, f star g plus h equals f star g plus f star h. That is the distributive property. What is associativity? F star g star h equals f star g star h. This is the associativity. Okay. So the convolution is always commutative as well as it is distributive and associative. Clear? Now, using this convolution, now we check how to solve a problem. So, come to a first problem. Using convolution property. Using convolution property of Laplace transforms, find L inverse of 1 by s into s square plus s square. 1 by s into s square plus s square. So listen, it is of the form L inverse of f of s into g of s. Okay, for put f of s equals 1 by s, comma g of s equals 1 by s square plus s square. F of s equals 1 by s, g of s equals 1 by s square plus s square. So the given is of the form L inverse, come on, it is of the form L inverse 1 by s means f of s into then 1 by s square plus g of s, s square, that is g of s. L inverse f of s into g of s. We know that. L inverse of f of s into g of s, the inverse Laplace of the product f of s and g of s is nothing but the convolution of f and g, that is integral 0 to t f of t minus u g of u du. Okay. Now listen, f of s equals 1 by s. So what about f of t? F of t equals L inverse of f of s. Okay, means L inverse of 1 by s. What is L inverse of 1 by s? It is 1. Agreed? What is g of t? G of t equals L inverse of 1 by s square plus a square. What is L inverse of 1 by s square plus a square? So, we know that. What is L 1 by s square plus a square? Come to the denominator. The denominator of the form s square plus a square. Yes, its denominator is same as the Laplace transform of sin at, but on numerator a is missing. Okay. So, it is nothing but L inverse of 1 by a into a by s square plus s square. Okay. So, that is 1 by a into L inverse of this one by the linearity. What is L inverse of this one? It is sin a t. So f of t is 1 and g of t is 1 by a sin a t. Therefore, integral 0 to t f of t minus u g of u du equals, what do you get? Integral 0 to t, what is f of t? F of t is 1, that's a constant function. Therefore, what is f of t minus u? That's also 1 itself. Okay. F of t is a constant function, therefore f of t minus u is also that constant, that is 1 into g of t, 1 by a sin a t. So what is g of u? 1 by a sin a u du. Replace t by u. That equals 1 by a into, what is the integral of sin a u? Sin a u means minus cos a u by a. From where to where? 0 to t. Okay. So that is minus 1 by a square into cos a u, cos a t, minus upper limit, sorry, lower limit, cos 0 equals minus 1 by a square into cos a t minus what is cos 0? 1 equals 1 by a square into 1 minus cos a t. Agreed? So it is 1 by a square into 1 minus cos a. This is L inverse of f of s into g of s, that is L inverse of 1 by L inverse of 1 by s into s square plus s square equals 1 by a square into 1 minus cos a. Clear? Right. So this is the method to solve the problem by using convolution. Okay. So come to another one. Find L inverse of another problem is find L inverse of 1 by s square into s minus a. L inverse of 1 by s square into s minus a. So listen, here again let f of s 1 by s square. Let f of s equals 1 by s square and g of s equals 1 by s minus c. Okay. So the given is of the form L inverse of f of s into g of s. So we can use convolution property. So when f of s is 1 by s square, what is f of t? L inverse of f of s. Clear? That is L inverse of f of s equals L inverse of 1 by s square equals t. What is L inverse of 1 by s square? T. Why? Because L t equals 1 by s square. So L inverse of 1 by s square is t. Okay. So this is f of t. What is g of t? G of t is L inverse of g of s equals L inverse of 1 by s minus c. What is L inverse of 1 by s minus a? L inverse of 1 by s minus a is e power at. So this is g of t. But the given is L inverse of 1 by s square into s minus a. It's of the form L inverse of 1 by f of s into g of s. So it is nothing but the convolution. That equals, left side equals integral 0 to infinity, sorry, not 0 to infinity, 0 to t. Integral 0 to t f of t minus u into g of u du. Okay. Means it is f star g. convolution of f and g. So, but we know that this f and g, the convolution is always commutative. So this f star g is same as g star f. That's only for sake of situation. You may solve this problem by using f star g also. Okay. What is g star f? G star f is integral 0 to t f of u into g of t minus u du. Do you have any confusion? F of u minus u into g of u du, that is f star g. But we know that commutative convolution is always commutative, that is g star f. What is actually g star f? It is g of t minus u into f of u du. Means integral 0 to t f of u g of t minus u du. Agree? So that equals integral 0 to t. What is f of t? T. That's already obtained. So what is f of u? U. So u into g of t e power at. So what is g of t minus u? Replace t by t minus u. So what I get? E power a into t minus u du. Okay. That means e power at is is constant with respect to u. So it is e power at goes outside of this integration. E power at into integral 0 to t. E power at into integral 0 to t. What remains here? U into e power minus au du. Okay. U into e power minus au du. If you solve the problem by using this relation, it is integral 0 to t minus u into e power at. T minus u into e power at. You can solve that problem also by using that method. Okay. So this equals e power at into, then how to integrate this one? Integral 0 to t u e power minus au du. That is integration by parts. So what I get? First function into integral of second. What is integral of e power minus au? E power minus au by minus a. From where to where? 0 to t. Minus integral of derivative of the first function. Derivative of u is 1 into integral of second function. Again, integral of e power minus au is e power minus au by minus a from 0 to t du. Okay. That equals e power at into, then e power at into, yes, minus 1 by a into, minus 1 by a into u e power a. When upper limit, it is t into e power minus at minus lower limit u 0. So finished here. Minus again integral 0 to t minus of minus plus 1 by a into what remains? Integral 0 to t e power minus au du. Again you can integrate it as it is integral minus au by minus a from again 0 to t. So its second term is minus of 1 by a into minus a. So it is minus 1 by a square into, it is upper limit e power minus at minus e power 0 1. Okay. So it is e power at into minus 1 by at e power minus at. This minus 1 by a square into that one. So you can rearrange it. Agree. So this problem is here we use f instead of f star g, g star f. What about this problem if you using the first argument? That means f of t minus u into g of u du. If you try to solve the problem by using this argument, so what do you get? It equals integral 0 to t. What is f of t? T. So what is f of t minus u? T minus u. Into what is g of t? E power a t. So what is g of u? E power au du. Okay. So that equals integral 0 to t into e power au du minus integral 0 to t u into e power au du. Listen, u into e power au du. Again, you can apply integration by parts like in the previous case. Okay, so you have the same answer. After you simplifying that, you will get same answer. So this is the convolution property. So the convolution property is used to solve the problems like this one. L inverse of f of s into g of s. Okay, so that property is important. If f star, the convolution of f and g is denoted as f star g and is defined as f star g of t equals integral 0 to t f of t minus u into g of u du, and the properties or the convolution is commutative, associative, as well as it is distributive. Moreover, the convolution of f and g is nothing but the inverse Laplace of the product f of s into g of s. That's an important result. That is, L inverse of f of s into g of s is f star g of t. That means it equals integral 0 to infinity f of t minus u g of u du. Okay, thank you.